Welcome to lesson 2.4. If you remember, in the last lesson 2.3, we were working on factoring polynomials. That was the whole key idea, is to get a polynomial into factored form. And to do that, I provided you with 1 0, and then you used division to fully factor the rest of the problem. In this lesson, instead of me giving you 1 0, I'm going to teach you guys how to find it. You do that using the potential rational zeros theorem. Now, a little bit vocabulary before we get into this. Just a little reminder, rational is anything that can be written as a fraction. So like 1.5 can be written as 3/2, or 0.3 repeating can be written as 2/3. Basically, anything that has a decimal that ends up repeating itself, like 0.3 repeating, or a decimal that terminates, meaning it stops, like 1.5 stops. Those are decimals that can be written as fractions. So, what about numbers that are not rational? We call these numbers irrational. And these are decimals that either go on and on and on forever and ever and never repeat. Things that we cannot write as a fraction. So, a very popular irrational number is pi. That is a number that goes on forever and ever and never repeats. That's an irrational number. Another one is root 2. In fact, most square roots are irrational. The only square roots that are rational are the ones that can be simplified, like square root of 9 can be simplified to 3. Now, if we take the family of irrational and rational and put those together, so the irrational plus the rational, we call those numbers real numbers. So real numbers are a combination of your rational and your irrational numbers. Real numbers are anything that can be written as a decimal. Those are your real numbers. And we will be talking about numbers that are not real numbers. Those are imaginary and complex numbers that we'll be talking about in the next lesson. So, now that we've defined all those vocabulary, we know what rational means, irrational, real, all that good stuff. Now we can come here and look at my potential rational zeros theorem. Notice that this theorem will only give you the rational zeros. If you have irrational zeros, things like using the quadratic formula to find the square roots, this will not help with those. This will only find the rational one, the rational x-intercepts or zeros. Now, it also is only there to give you a list of possibilities. So let's talk about how to come up with this list. This list is of the form P over Q, where P is the factors of your constant and Q are the factors of your leading coefficient. So let's practice this in example 1. Notice example 1 just says list all the possible rational zeros. So we're going to do this P over Q. So the factors of the constant over the factors of the leading coefficient. So if I look at this equation, my constant is -3. So if you think of the things that multiply to -3, we've got -1 and +3. By the way, that's what factors mean, things that multiply. And we've also got +1 and -3. Those are the two things that will multiply to -3. Divided by the factors of my leading coefficient. My leading coefficient is 2. So the factors of my leading coefficient are 1 times 2 will get me to 2. And then I can also do -1 times -2 will also get me to 2. So these are all our factors. And just so you know, there is a shortcut for writing this. Instead of writing a -1 and a +1, we could write plus and -1. Instead of writing a +3 and a -3, we can write plus and -3. And then same thing with our denominator. Plus or minus 1, plus or minus 2. It's just a shorter way of writing the same thing. So now that we've got our factors listed out, now we can list our possibilities. So our first possibility is going to be plus or minus 1 divided by plus or minus 1. So if I had a plus 1 divided by a plus 1, that gives me a positive 1. If I had a positive 1 divided by a negative 1, that gives me a negative 1. So plus or minus 1 divided by plus or minus 1 gives me plus or minus 1. Next, let's stick with the 1, but now we're going to divide it by the 2 instead. So plus or minus 1 divided by plus or minus 2, plus or minus 1/2. So we took the 1 to everything in the denominator. Now let's take the 3 to everything in the denominator. So plus or minus 3 divided by plus or minus 1 gives me plus or minus 3. And finally, take the 3 to the 2. Plus or minus 3 divided by plus or minus 2 is plus or minus 3/2. So this is our list of possible zeros. That does not mean that all of these are zeros, because you'll notice that this is a degree 3 polynomial, so I should have 3 zeros. So all of these definitely don't work. I have 8 possibilities. Positive 1, negative 1, positive 1/2, negative 1/2, and so on and so forth. 8 different possibilities. I only need 3. So the next question is, how do I figure out from my list of possibilities which one of these possibilities is an actual zero of this equation? Which one actually works? That is found using our friendly synthetic division. If you remember when we talked about in 2.3, how do we know from synthetic division if something is a zero or a factor? We get a remainder of 0. So I'm going to take these and I'm going to do synthetic division with them and figure out which of these has a remainder of 0. If it has a remainder of 0, then that is one of my zeros and therefore one of my factors. So in the next video, we're going to start testing this list of possibilities out and find out which one works.